we called as time consuming and degrading your joins performance. That means a join query performance will be degraded because this much internal process it will be going to happen. Understand now? So then in this case, what happened? My join performance will be degraded. The performance of joins are degrading here. This is actually the problem. Okay, now this is the main problem why we need to create a clusters to overcome this. Okay, so this is what joint performance will be degraded here. Now, what I want to do, I don't want to degrade my joint performance. I want to improve. So whenever you need to improve the joint performance, okay, definitely what should we want to do? We need to create a clusters. The same concept, let me go for the clustered, how it will be work. Okay, now the in clustered, so again you are same, you have to take one database now. Okay, now clustered advantage is what now? At the time of tables creations, whatever the table are you created, at the time of table creations, that all tables together, we are keeping into one data block memory. And those tables, how it will be keep here means already the tables will be joins together. Okay, along with joining those, okay, along with joining, the tables will be saved in your clustered memory. And how it will be joining, sir? How it will be joining, sir? Means that these tables will be joining here. Okay. So based on your common column name. So common column name, what it was there, the table number 1 and table number 2 and table number 3. So at the time of table creation, based on a common column, that all tables, how many tables you need to keep under clusters, the tables will be clustered and keeping under same data block memory. So your clustered means what now? All are to be connected. All tables are going to be connected. So it will be connected, and how you connected based on common column. So common column basis, all are going to be joined like this. So it will be joined like this and keeping under same data block memory. Okay, now, then if it was there like this, okay, then how many data blocks here? Only one data block. So now all are together. Then what it was happen on this clustered tables, now you can write your query. Select a star from T1, T2, T3. Same as usual condition. T1 dot common column is equals to T2 dot common column, and T2 dot common column is equals to T3 dot common column. Okay, now right. So now same as usual request we are sending to server. Server, what it will do, it is internally what happened. These two are separate conditions, yes or no? But these two conditions will never check. Why it is never checked? Because already based on your common column only, your data, 3 tables data already joined. Already link was established already. So again, I don't want to link my tables. Yes or no? So already joined. So that's why this condition is not necessary to verify. This condition is also not necessary to verify. Because at the time of creation, already your tables will be joined. Okay. Then what it will do directly, it will be going to apply here, end operation will be applied. So end operation will be applying on this 3 table data. Then immediately the 3 table, from the 3 table, it will be written what now? Final result. And the final result is sending to client or user. See how much fastness. Okay, now here no need again first table to table join, table to table join. After joining results keep, and there you can apply end and final result and send. So this much internal process is not necessary. on the tables when we perform joins and without a cluster. Yes or no? So without the clusters, this much need. Okay. But with the cluster, we don't want it this. So because directly your tables will be clustered already. And those clustered table, directly we applied what now? Join operation to fetch your necessary data immediately. So in this case, what it was happened, my join query performance, my join speed, the query execution speed is very fast. Understand? Na? So this is what we called as clustered advantages. So that means what you say, clustered, sir, we are creating only the reason to improve the performance of joins. That's it. This is the main cause why we want to create a cluster. If anybody asks your interview panels, okay, what is clustered and why we want to create a cluster? What is the advantage? So cluster means what now? It's a group of tables together sharing in same data block memory. Okay, now that is called a cluster. So why clusters are required? To improve the join performance. And advantage is what now? Time saving and improve your join performance. Okay, now? So these are the points you just go to explain to them. If anybody asks you why we need to create a clusters. Okay, right. So now write down some points here. So it is a database object. It is a database object which contains group of tables, together, and sharing same data block memory. Now, clustered can be created. Clustered can be created to improve the performance of joins. The performance of joins. Next point. When we create cluster tables, we should have a common column name. So this is mandatory. Okay, na? We should have a common column name. Otherwise we cannot create cluster tables. And now these clusters or clustered can be created. Clusters can be created at the time of creating tables. At the time of creating table. Can be created at the time of creating tables. See, after tables, you cannot. Along with the table creation only, you will be create your cluster. But somebody is asking to you, can I create a cluster on existing tables? Never. Impossible. Okay, na? Clusters can be created along with the table creation only possible. After table creation, it is not possible. Okay, na? Right. So cluster can be created at the time of creating tables. Full stop. And these clusters who will create it generally in real time means it will be created by database administrators. Okay, na? So clusters can be created by database admins. So these are the people, they will be creating these clusters on your database memories. Okay, right. Now, if I want to create these clusters, there is we need to follow some steps here. Okay, there are 3 steps are there to creating your cluster tables. Okay, so I'm giving here steps to create a cluster. Cluster tables. Okay, right. So what are the steps here? Observe. The step number 1. First, we create a clustered object. Create clustered object. So how to create clustered object here? Okay. So what is my syntax for this? Create clustered and give it your cluster name. Okay. And should be take what I'm saying here, common column name. The any one common column, you will be fixed first of all. Based on that, you can create now. Okay. This is size. Step number 1. Step number 2. After that, create an index object. Create an index on clustered object. So indexes are we're creating what now to fastly accessing purpose. So that should be create on cluster memories. Okay. So how to create index and give it your index name on clustered and give your cluster name. Okay. This is your second step. Step number 3. Now we can go to create cluster tables. Create cluster tables. So in this, what is the syntax of to creating cluster tables? So as usual, first you have to create your table, okay, and with some column names here. So okay, so I want to create column name 1 and give it your data type, whatever you want it, and later you can go for size. So and so on, like you can create, and after that you can add your tag here, cluster name of a common column name. Okay, so based on this common column, we are preparing cluster tables. That means this common column through your tables can be joining. Yes or no? One by one it will be joined and keeping under same memory. That's the point. So now these are what now? The 3 steps mechanism. Okay, let me come. So first I will go to show you how to create here. Okay, right. So let me come out. What is the first step here? To create what now? Clustered. So my cluster name something I was taken EMP underscore DEPT and one common column here, department number. So my cluster was created. After that, create an index object. Okay, create index cluster index CI. Okay, on my cluster and cluster name emp underscore dpt. So index is created. Now you can create your tables. Okay, now now create table. My table name is, for example, emp 44. Suppose ID and some name. And what I said, compulsory common column should be maintained. Without common column, we cannot create a clustered memories. So what is my common column? Department number. So which column are you taken here at the time of cluster creation? That column should be maintained in your tables. Then only clusters can be joined. Otherwise, it cannot join it. So department number. Okay, fine. Oh, sorry, guys. Okay, now I want to go for not should be break, and we need to add this table to whom cluster. What is the cluster name? emp underscore dpt. On which column basis? dpt number column basis. Now you can create. Now cluster table is created, and same in the same memory, I want to add one more table. So create table dpt 44, and here I'm saying a department number and department name. So your department number is my common column. So this table is also I'm adding to clustered. So clustered, which cluster I'm adding? emp underscore dept. And what column basis? Department number column basis. Okay, fine. The two tables are created successfully. And these two tables are having under which cluster memory? What is your cluster name? emp underscore dpt. In that memory, the both are joining and kept into that. Okay. Now, after that, you need to insert some records in your table emp 44, sending values 1 comma a comma department number is 10. The same as you have to go for 2 comma b comma department number 20, and I just made it commit to permanently save. And same as you have to do in your department 44 also. So now I'm passing here 10 comma department 1 d1. Okay. Then after that I can go to pass here 20 comma department number 2. Okay. And let's make it what? Commit. Then after you can come back and see your emp 44 and data will be there here, and dpt. So DPT 44, then you can see. So now this is what it was happening here, clusters, tables here. But sir, how I knows these two tables are having in the same memory? How we can know it? Okay, na? For example, I said here, yesterday some friends group is there, and your first friend is going to be booking 4 rooms here. Yes or no? For your 4 people. He was booking some rooms. And every room is having some number 101, 102, and 103. Okay. And each room is allocating one person. Okay. Now, each room is allocating one person. Okay. Now tell me. So A and B and C, the 3 people was staying in different rooms. Okay. If I'm going to asking to person B, what I'm asking to B, what is your room number? And what he was say, 102. If I'm asking to a person, what is your room number? He will say 101. And I'm asking to C person, what is your room number? He will say 103. Sir, you tell me why these different people telling different room numbers? Because they're staying in a individually. Understand? Na? So that means these are clustered or non-clustered? Non-clusters. So non-clusters, that's why every individual person having its own separate room. And the room numbers will be different, definitely. Yes or no? This is non-clustered. But suppose what the second example we discussed yesterday, another friend is booking only one room. And the one room, okay, the number is what now? For example, 101. In this, 3 people are staying now. The same room, three people are saying that A, B, C. Now we can ask to B person what he was saying. 101 he was saying. What if you ask to A person? He is also telling same ID, that means same room number. C person 101. So why sir these three different people but telling same room number? Because of reason these three people are staying in same room. So this is what we called as a clustered. This is called as what now? Non-clustered. Okay. Same as how we can differentiate the room numbers here and same room number, how we can consider, okay, whether these people are grouping or individual, how you consider, same as here two tables I created. And what I'm saying here, these two tables are having in the same memory. So whenever the two tables are having in the same memory, that means this two table row identities also having same now? Yes or no? Yes, definitely. Suppose these two tables having rows and these two tables row IDs are showing same, then you confirm that these two tables are having in the same memory. If the two tables row IDs are showing different, then you can confirm these two tables are different data blocks. That means non-clustered tables. Okay, na? So row IDs are permanent or temporary? It's a permanent. It never change. So now let me call to identify these two tables are having in the same memory or not. So EMP 44 row IDs. Okay, now? Next, you have to go the row ID from DEPT 44. Now see, both the rows or both the table rows IDs are same or different? Same. So first row KB triple A, first row KB triple A, second row KF, second row KF. So both IDs are same. This is one practically you can show them, okay, whether my tables are clustered or non-clustered. This is one thing. Second one is what now? Even though if you want to know it, whether these tables are clustered or not, then you can go to tab list. In tab list, can you see these all are having the objects, whatever it is. But can you see here table name, the table, that's a tab type, and what is this? Cluster ID. Suppose you can come out and see my DEPT 44 clustered ID number, how much showing? 2, and the same as EMP 44 clustered 1. So these are called as a clustered ID numbers. When your tables are when your tables are having in the clustered memories, definitely those tables was having some identities here. So these identities you can see 1 and 2. And what is your clustered name? Can you see your clustered name? What is this? EMP underscore DEPT. What is this? Clustered. It's not a table. It's a clustered object. So in this clustered object, they have a two tables, EMP number 44, it's ID number 1, and DEPT number 44, it's ID number 2. So see, only these tables are having clustered IDs and remaining tables are not showing. Yes or no? Remaining tables are not showing means what now? These are non-clusters individually. These are, okay, na? But these two tables only under clusters. So that means in clusters, how many tables I kept? Two tables. EMP 44, DEPT 44. Those IDs are 1 and 2. Okay, na? So this is another way you can show them the clustered tables, or my tables are clustered, non-clustered. And one more way you can show it. What is that here? Okay, you want to know in my clustered memories how many tables I kept. Okay, there is one more data dictionary is there. In data dictionaries wise also you can confirm it. User underscore tables. In user underscore tables, can you see here table name and cluster names are there. So now let me come out and see. I'm writing here select table underscore name from What is the data dictionary? User underscore tables, and where table underscore name, cluster underscore name is equals to, what is my cluster name? EMP underscore DPT. Let me see. Now tell me, in this clustered memory, how many tables you have? Two tables, number 44 and department number 44. So like this also you can show whether my tables are having in clusters or non-clusters. Okay, now? So these are the three ways you can tell them to anybody ask you, how can you say my tables are under clusters? Okay, these three things you can show it them. Okay, now? Write down. Hmm. Now write down. Completed? Completed? Huh? Right below. To know the above tables, to know the above tables are in clustered, are in clustered, then we see, or then we check row IDs. Then we check row IDs of both the tables. Both tables. If both tables, row IDs are same, then those tables, are in clustered memory. Otherwise, in non-clustered memories. Otherwise, in non-clustered memory. All right now. Okay, right. So these are clustered creations. Okay, below right on note point. So to view all clustered objects, to view all clustered objects in database, Oracle database, then use a data dictionary is a user underscore clusters, user underscore clusters. So in this, data dictionary, we can see it, our objects here, how many clustered objects are there here that we can see. Okay, so desk user underscore clusters. And now in this, what is here? Cluster name was there here. So select from user underscore clusters. How many clusters as of now? Only one cluster. The cluster name is what? EMP. Right on below. The next node point. To view clustered tables in Oracle database, then use a data dictionary is user underscore tables. So I already show you, this is our data dictionary through, you can see it this right now. Okay, so clusters creations and how we can say it. And now below write down how to drop a cluster. Okay, now you can see when we are using the syntax of clustered here, suppose drop cluster, and I want to send my cluster name up to here. If I written like this, what it was happening, you can see. So now I'm using drop cluster, and cluster name is what now? EMP underscore DPT. So up to here, when you try to drop your cluster, it was showing some error. And what it was say, cluster not empty. So actually the cluster memory is not empty because in that we have a tables also. So that's why we can't go to directly drop like this. Okay. But how I can drop? So I can drop here. One statement should be add here. So including tables. When you do including table statement, when we add along with your drop command, then only clusters can be dropped. But the thing is what now, once you drop your cluster memory, then this tables also dropping. Let me see whether the tables are having or not in my tab list. Check it out. Having here? No. So your cluster IDs are not showing and cluster is not there. Along with cluster, table is also deleted. Okay, no? Right down below. Okay, right. So below, take a small diagram on this. Take this diagram. So one side non-clustered and one side clustered. Completed. And below that point also write down to degrade joint performance and here to improve joint performance. Okay. So this is the main cause of clusters. Okay. So that point compulsory write down below. Completed. Huh? Okay. Okay. Right. And two more topics are there in SQL part. One is normalization topic. Okay. No? One is user defined data types. Okay. No? Then after we enter into PLSQL. Okay. Okay. The next topic we will discuss on tomorrow's session. Okay. Uh, so, right, guys. And online students, I will interact with you tomorrow. Okay. Right. First, I will go. Huh?